Hello students. Today we will start our unit number 4, that is PLC wiring diagram and the ladder logic. Now in this unit we will study the ceiling circuit using PLC, the concept of ceiling and why we are going to use the ceiling circuit, that is also called as the latching circuit. Then we will discuss the ladder and wiring diagram of DOL starter. DOL stands for your direct online starter with OLR. OLR means your overload relay. Then we will discuss the latching relay using PLC. This is the most important concept used for PLC programming. Then next we will discuss the PLC based water level controller. Here we will just this is the application base in which we will maintain the water level in the tank constant. Okay, so when the water level decreases, it will start the motor. When the water level reaches to the predetermined value, it will stop the motor. Then we will discuss the forward and reverse control of three-phase induction motor using PLC. Sometimes we need to rotate the motor in forward direction, sometimes we need to rotate the motor in reverse direction. So how to do that? By using the single motor. You can just discuss in this example by using PLC. Then we will discuss the temperature control on off. So in this case, we will take one application in which when temperature reaches to the certain value, the system is going to be on, and when temperature decreases to the certain value, the system is going to be off. Or depending on the temperature value, we will operate the system in two modes. That is, the system may becomes on or it may be off. Then we will discuss the stepper motor control. So this is also application based in which we will discuss the stepper motor, and the last case for this unit is the bottle filling system. This is the actual application based system in which we will study the bottle living system. Now first we will discuss the sealing. Sealing or holding circuits are very common in both relay logic and PLC logic. Essentially, in sealing circuit is a method of maintaining current flow after the momentary switch has been pressed and released. In this type of circuit, the sealing contact is usually in parallel with the momentary devices. Now, basically, we have two types of switches. One is your press and hold switch, and one is your press and release switch. So the press and hold switch that you are going to use in your home for controlling the fan, for controlling the lamps. Okay, when the switch is pressed, it will remain in that state. Either if it is in on state, so it will remain in the on state. Okay, when you are going to again press it, it goes in the off state and it remains over there. So this is called as press and hold type. Okay, so it will maintain the state. Second switch that you are going to use for doorbell is the press and release type switch. Okay, so in that press and release type switch, as long as the pressure is applied on the switch will remain in the energized states. Once the pressure is released, okay, once you remove your finger from the switch comes to it will disconnect the circuit. Okay, so this is the press and release type switches. Now, for industrial control, we will prefer the press and release type switches. Those are called as momentary press switches. Now, what is the use of for this one? So basically what happened, take an example, if an operator is working on the machine. Now, when the operator is working on the machine, so it may be there is a hacksaw blade. The hacksaw blade is cutting the wooden piece over there. Now, the operator has put his fingers or his hand on the wooden block and he is just putting the wooden block under the hacksaw blade. Now, if I am using the press and hold type switches over there, what happen? The system remains on. Now, suppose the power failure will occur, the system will stop. Now when the system will stop, the operator is going to be relaxed. Okay, and when the operator is relaxed, as system is not working over there, he may casually place his hand over there, and if the power will suddenly restore, okay, so the machine will automatically start without giving any early warning. Now, it might be possible that the operator may get injured because of the sudden start of the machine. Okay, say if the hand of the operator is just near the hacksaw blade start running once the power will restore, so there may be the injury to the operator. And in some cases it may result into the casualty also, the operator may die in those cases also. So this is very risky situation. To avoid that, what you are going to do, we are never recommended to use the press and hold type switches over there. Instead of that, we are going to recommend the press and release type switches over there. What happen in the press and release type switches? So when the switch is pressed, at that time the machine will start. Okay, and when the power failure occur, at that time what will happen? When the power failure occur, at that time the machine will stop. Okay, but again when the power is restored, the machine does not start by its own unless and until the operator will press the button. So how it is possible, that we are going to discuss with the help of this ceiling circuit. Now the motor stop start circuit is shown in the figure that we are going to discuss just is a typical example of ceiling circuit. The hardware circuit consists of normally closed stop button in series with the normally open start button. So here we are, what you are going to do, normally close is your stop button, NC type is always stop button and NO type is always start button. The ceiling auxiliary contact of the starter is connected in parallel with the start button to keep the starter coil energized when the start button is released. When this circuit is programmed into the PLC, both start and stop buttons are examined for closed condition because both buttons must be closed to cause the motor starter to operate. Now this is the diagram here. How you are going to implement this? So this is my start push button, this is my stop push button. So here this is a push button. Okay, we are not using push and hold type buttons, or this is push and release type button. Okay, so once you are going to press it, okay, the circuit will complete it. Okay, start button is always NO type and stop button is always NC type. This is NO type and this one is your NC type. So when you are going to press this button, the current will flow from L1 to start, start to stop, stop to motor coil. The motor coil get energized, and L2. Now what happened when you are going to release the button? If this M is not there, the motor will get stopped. So I want to maintain the motor in the start condition. So what I am going to do over here, I will place one auxiliary contact of this contactor, motor contactor, in parallel with the start button. Okay, so now how it will operate? When the start button is pressed, the current will flow from L1, L1 to start, start to stop, stop to M, M contactor get energized, L2. Okay, then when the M contactor is getting energized, its auxiliary contact M is going to be closed. Okay, and after releasing the start button, the second path for the current is L1 to M and M to stop and stop to your motor, and the motor remains energized. Okay, unless and until someone press the stop button. Okay, or unless and until there is a power failure. Now if this is my hardware logic. If I want to implement in terms of the program, how you are going to do this one? So for that purpose I have to use two separate buttons, one for starting purpose and one for stopping purpose. Okay, this button is used to start the motor, this button is used to stop the motor. Now in that case what you are going to do over here, so, and this is my output coil, this is the contactor which is connected as the output over here. Now this is actual program which we are going to put into the your PLC. So I have placed one start button over here which is NO type. I have placed one stop button over here which is NC type. This is my motor coil, and the auxiliary contact of this motor coil, this is M, is connected in parallel with the start button. Okay, so when the start button is pressed, the coil get energized, his auxiliary contact get energized, and the motor starter coil remains energized through the auxiliary contact M stop. Okay, now how to make the connections over here, that we are going to discuss. Say this is my PLC, this is the input module of PLC, this is the output module of PLC. To the input module we are connected to the I1 switch, I1 to the input number 1 I have connected the stop button, to the input number 2 I have connected the start button. Now when the start button is pressed, the motor will start, when the stop button is pressed, the motor will stop. Now here this is my coil Q1, this is my program which is placed inside the PLC, and this is my output. To the output Q1 I have connected one motor. Okay, so motor is connected in such a manner that it's L1, this is your phase and neutral over here, so it is L1 and this is the L2. This is the relay type output module. There are different types of output modules available in the market. We are using the relay type output module. Okay, and now this ceiling circuit is not external over here, this is the programmable ceiling circuit. Okay, we are not placed the latching contact external. It is my internal latching contact. Okay, so I can use n number of latching contact. That will drastically reduces my complexity in the wiring, hardware wiring, and that is the beauty of your PLC program. Now we will just implement the circuit, this circuit into the software. So for that purpose, we will just go for Logosoft. In Logosoft, I will change to the ladder. Now I will take one contact over here, and I will take its simulation. It is momentary push button. Okay, here remember, I have not taken it as a push and hold type. I have taken it as a momentary push button. Then this is my stop button. I have given the name here, it is stop. Okay, and its simulation is again momentary push button. So this is momentary, this is start. The parameter one is okay. Then for this one, this is simulation is, we have selected momentary push button, and it is a stop push button over here. Then I have connected one more here. This is my i3. Okay, and the name for this i3 is OLR, overload relay. OLR over here. Okay, and then I need a output coil over here. So this is my output coil. So we'll check how it will work now. Now I will go to the simulation over here. So when I will press the button, my output will on. You can just check over here. We have pressed the button, the output will glow. But as soon as I will release the button, the output will stop. But I don't want that. I want that my machines should be remain in the energized condition as long as the button is stop button is not pressed. So what I am going to do, I will put one auxiliary contact of your output in parallel with the start push button. So I will just put the auxiliary contact of output in parallel with the start push button, and this contact is called as seal-in contact. Okay, this is my seal-in contact over here. Now again we will take the simulation over here. Now what I am going to do, I will press the start push button over here. Now I have pressed the start push button and I release it. You can observe here, I have pressed it and I have released the start push button, but still my output remains on. Okay, as long as I am not going to press the stop push button. Once I will press the stop push button, my output will de-energize. Okay, if I want to again start the machine, okay, so even though now if the power will restore, my machine does not start directly. I have to again press the start push button. In case of overload relay also, if my machine get overloaded, at that time by pressing this switch, the machine will get disconnected. Again this pressing this switch, and when you are going to press the start push button, the machine will start. Okay, so this is how you are going to use the dual starter. Okay, so in dual starter we have start push button as well as your stop push button. The start push button is NO type and stop push button is also always NC type. Okay, OLR relay and seal-in your output over there. The output's auxiliary contact can be used as a seal-in contact over here. This is Q1 is my output relay coil, and that's auxiliary contact I can use over here as a seal-in contact. Okay, so this is all about your seal-in contact, which is used for your PLC program.